Advanced Database Security, Protecting Your Organization's Most Valuable Asset, Horizon lecture script for Mr. Bell, Ctech, CaesarBrotherTech.com. Introduction. Good morning, everyone. My name is Mr. Bell, and I'll be your guide through this comprehensive course on advanced database security. Welcome to Lesson 6, where we'll dive deep into the critical world of protecting your organization's most valuable digital asset, its data. Database security isn't just about keeping unauthorized users out. It's a holistic approach that encompasses data integrity, privacy, availability, and regulatory compliance. By the end of today's session, you'll understand the sophisticated measures necessary to safeguard your databases from increasingly complex threats. Let me ask you this. What happens if your customer payment information is breached, or if patient medical records are exposed? The consequences extend far beyond just technical problems. We're talking about severe financial impacts, damaged reputation, legal consequences, and potential harm to individuals. That's why this topic deserves our full attention. So let's dive right in and explore the 5 critical components of advanced database security. Part 1, Encryption Techniques. Encryption is your first and often most powerful line of defense. Think of encryption as a sophisticated lock system that ensures your data remains scrambled and unreadable to anyone without the proper key. There are 2 primary categories of encryption you need to understand. First, data at rest encryption. This protects your stored data when it's not actively being used. Imagine your database as a vault of valuable information sitting on physical storage. Data at rest encryption ensures that even if someone physically steals your storage devices or accesses your backup files, they can't read the contents. Common solutions include transparent data encryption, TDE, in SQL Server or Oracle, file-level encryption tools. Full database backup encryption. The second category is data in transit encryption. This protects your data as it travels across networks. When your application sends a query to the database or retrieves information, this encryption ensures that anyone who might intercept that traffic sees only scrambled data. This protection typically uses TLS SSL protocols, which create a secure tunnel for your data to travel through. It's particularly important for preventing what we call man-in-the-middle attacks, where attackers position themselves between communicating parties. For truly sensitive information like credit card numbers, social security numbers, or medical information, we implement strong encryption algorithms with AES, Advanced Encryption Standard, being the gold standard. But remember, encryption is only as strong as your key management. A robust key management system, KMS, is crucial to prevent unauthorized decryption. Think of it this way. Encryption turns your valuable data into indecipherable gibberish for anyone who doesn't have authorization to view it. It's your digital armor. Part 2, Access Control and Authentication. Now let's talk about who can access your database and what they can do once they're in. This is where access control and authentication come into play. User authentication is how we verify users are who they claim to be before granting access. The most basic form is the username and password combination, but in today's security landscape, that's rarely sufficient on its own. That's why we implement multi-factor authentication, MFA. This requires users to provide multiple forms of verification, typically something they know, password, something they have, like a mobile device receiving a temporary code, and sometimes even something they are, biometrics like fingerprints. Once a user is authenticated, the next question is, what should they be allowed to do? This is where authorization comes in. The most common approach is role-based access control, RBAC. Rather than assigning permissions directly to individual users, we create roles that match job functions, then assign users to these roles. For example, a read-only analyst role might allow viewing data but not changing it. A data entry role might allow adding new records but not deleting existing ones. An administrator role would have broader permissions. This approach implements the crucial security principle of least privilege. Users should only have the minimum permissions necessary to do their jobs, nothing more. Some database systems also support what we call fine-grained access control, FGAC. This takes security to an even more granular level, controlling access at the row or column level. For instance, in a medical database, a doctor might only see records for their own patients, while a billing specialist might see billing information, but not medical details. This granular control is typically implemented using views that filter data appropriately, row-level security policies, column-level encryption. By implementing these controls properly, you create a carefully gated system where users can access exactly what they need and nothing they don't. Part 3. Database auditing. Even with strong encryption and access controls in place, we need to monitor and track what's happening in our databases. That's where auditing comes in. Database auditing is the process of recording and analyzing database activities to detect suspicious behavior, ensure compliance, and provide accountability. Think of it as your database's security camera system. Most modern database management systems like SQL Server, Oracle, and MySQL have built-in auditing capabilities. You can configure them to track various activities, including user logins and logouts, data access patterns and queries, data modifications, inserts, updates, deletions, schema changes, creating or modifying tables, views, procedures, permission changes, failed login attempts. These audit logs become invaluable in several scenarios: detecting potential security breaches, investigating incidents after they occur, demonstrating compliance with regulations, understanding usage patterns to optimize security. For effective auditing, consider implementing centralized log storage separate from the database itself, regular log reviews and analysis, automated alerts for suspicious activities, retention policies that comply with your regulatory requirements. A well-configured auditing system acts as both a deterrent and a detective control. Users knowing their actions are monitored are less likely to attempt unauthorized activities, and if someone does try something malicious, you'll have the evidence needed to respond appropriately. Part 4. Compliance with regulatory standards. In today's business environment, database security isn't just a technical concern, it's also a legal requirement. Various industries and regions have specific regulations governing how data must be protected. Some of the most significant regulatory frameworks include GDPR, General Data Protection Regulation, applies to organizations handling EU residents' data. HIPAA, Health Insurance Portability and Accountability Act, governs healthcare data in the U.S. PCI DSS, Payment Card Industry Data Security Standard, requirements for handling payment card information. SOX, Sarbanes-Oxley Act, financial reporting and data requirements. These regulations typically require specific security measures such as mandatory encryption for certain data types, access control requirements, audit logging and monitoring, data retention and deletion policies, breach notification procedures. Regular security assessments, while compliance requirements can seem overwhelming, they actually align well with security best practices. By implementing robust encryption, access controls, and auditing, you're already addressing many compliance requirements. The key is to understand which regulations apply to your specific situation and ensure your database security measures align with those requirements. This often requires collaboration between technical teams, legal departments, and compliance officers. Remember, compliance is not just about avoiding fines. It's about protecting your customers, patients, or users whose data you're entrusted with. Dorisur, Part 5, Emerging Trends in Database Security. As we conclude our lesson, let's look toward the future. The threat landscape is constantly evolving, and security measures must evolve in response. Artificial intelligence and machine learning are revolutionizing database security. These technologies can detect anomalous access patterns that might indicate a breach, identify potential SQL injection attempts, predict vulnerabilities before they're exploited, automate responses to common attack patterns. AI-powered systems learn from past incidents and continuously improve their detection capabilities, making them increasingly valuable for database security. Blockchain technology is another promising area. While primarily known for cryptocurrencies, blockchain's distributed ledger technology offers interesting security applications for databases, immutable audit trails that cannot be altered, distributed verification of transactions, enhanced transparency for critical data changes. Finally, as more organizations move to cloud-based database solutions, database as a service, DBS security presents unique challenges and opportunities. Multi-tenant environments require stronger isolation. Cloud providers often offer advanced security features. Shared responsibility models require clear understanding of security boundaries. Data migration to and from the cloud introduces new security considerations. These emerging technologies don't replace fundamental security practices, they enhance them. The most secure database environments will combine traditional controls like encryption and access management with these newer approaches. Conclusion. Today, we've covered the 5 pillars of advanced database security. 1. Encryption techniques to protect your data both at rest and in transit. 2. Access control and authentication to ensure only authorized users can access your data. 3. Database auditing to monitor activities and detect potential threats. 4. Regulatory compliance to meet legal requirements. 5. Emerging trends that are shaping the future of database security. Remember that database security is not a one-time setup, but an ongoing process. Threats evolve, technologies change, and your security measures must adapt accordingly. At Ctech, we believe that understanding these concepts is crucial for anyone working with databases in today's digital landscape. Your role in implementing and maintaining these security measures is essential to protecting your organization's most valuable asset, its data. Are there any questions before we move on to our hands-on exercise where you'll get to implement some of these security measures in a controlled environment? Thank you for your attention. I'm Mr. Bell, and it's been my pleasure guiding you through the fascinating world of advanced database security.